Now we get the limits. Well, the deal was the limit as x approaches 0 of the sine of an angle divided by the same angle. So what we do, we need to modify this to make it look identically. One way of doing that is to multiply this by 3, basically by 1. This is the limit as x approaches 0 of 3 times the limit as x approaches 0 of the sine of 3x divided by 3x. If I let theta equal 3x, then that's matching. The limit of a constant is the constant. That's a 1 by definition, so this answer is a 3. So that's the idea. The idea is to make sure that the angle matches the denominator. Same thing with a cosine. If I look at this, this is the limit as y approaches 0. The cosine of y minus 1 over the sine of 2y. Well, to make use of this, I need to divide this by 2y and multiply by 2y, basically a 1. And here I need to divide this by y and multiply this by y. What happens now? This is matching the definition. So if I work those out here, let me just set them up. So I'm looking at the limit as y approaches 0 of y times cosine of y minus 1 over y times 1 over 2y, that will be this y, times 1 over the sine of 2y over 2y. So I'm looking at those individually. Well, algebraically this cancel out. I'm looking at this limit right here will be a 0. This limit right here will be a 1 because that's a constant, like 1/2. And this limit right here will be 1 over, this limit will give me a 1. So my answer would be a 0. And if I get to the last problem, this is the limit as x approaches 0. I've taken of this as the sine of 3x over x times the sine of 2x over x times the sine of 5x over x. Well, here I multiply by 3 top and bottom, here I multiply by 2 top and bottom, and here by 5 to match. And this turns out to be the limit as x approaches 0 of 3 times 2 times 5, that is 30, times the sine of 3x over 3x times the sine of 2x over 2x times the sine of 5x over 5x. Now I could say that's a 30 times 1 times 1 times 1, which is 30. Next problem up, again I want to match this with the definition. Limit as x approaches 0 of the cosine of x squared minus 1 over x. So what I do, I multiply this by x, limit as x approaches 0 of x, times the cosine of x squared minus 1 over x squared. Well, this limit will be a 0, and by definition, since the angle matches, that's a 0, and 0 times 0 would be a 0. Next problem up, this is the limit as x approaches 0. Cosecant is really 1 over sine, and since the angle matches the denominator and that approaches 0, by definition this is the same as saying it's the sine of theta over theta, that is a 1. Next problem up, that's the limit as x approaches 4. I need to get that angle. So if I factor this, that's x minus 4 into x minus 1. So that is the limit as x approaches 4 of 1 over x minus 1 times the sine of x minus 4 over x minus 4. Again, as x approaches 4, that approaches 0, so that applies. Throw a 4 in there, that's 1/3, and that's a 1 by definition, so the answer is 1/3. So that's how we do limits.